Okay, welcome back to part 4. In this video, we're going to be using our servo motor from last time, but we're also going to be adding in a potentiometer component as well. So if you haven't already, please head over to tinkercad.com/circuits and grab a breadboard, a potentiometer, and an Uno if you don't have one already. And if you do, make sure they're set up accordingly, because this has all been set up from last time and we know it all runs nicely. Now we're going to go ahead and get a potentiometer. So remember, if you don't have your components visible, you might have a button on the top that says components, and you can click on that. But mine are visible right here. So I'm just going to type in potentiometer and then grab the potentiometer component and just put it somewhere on my board where it's not going to cause a lot of interference. So I usually put it here next to the bridge. And the reason I do that is because in real life, potentiometers don't always have the 3 pins on the same side. Oftentimes you're going to have 2 pins on one side, the pins on the furthest left and right, and then this middle pin is going to be on the other side. So if you're building this in real life and you notice that one of your pins isn't on the same side and it's over here when you plug it onto the bridge or beyond the bridge, please make sure that the wire that I put over here, you put over on this side so that it still is all electrically connected. Okay, let's take a look at these. So we have terminal 1 here, we have a wiper, and we have terminal 3. Now, the terminal 1 is most commonly used for a ground, and the terminal 3 is most commonly used as the power. So a 5-volt power supply would be fine. And we have some resistances, and feel free to adjust these numbers and mess around with them. You can get lower resistances or higher resistances, and all that's essentially doing is when you have it clocked down, you have no resistance, whereas when you have it clocked up all the way, you have a lot of resistance. And typically, if you just are using a potentiometer from a kit, you're probably dealing with 10 kiloohms or so. So I'm just going to adjust that to 10 kiloohms and just leave it like that. Okay, so the terminal 1, I'm going to plug it into the ground. Okay. And the terminal 3, like I said, goes into a 5-volt, but there's one problem. I'm using the 5-volt for the potentiometer, but not a big deal. All we're going to do is delete that wire, and I'm going to take the 5-volt and kind of just navigate around my board and plug it into the positive. Okay, so the second I plugged it into the positive, all these ports here became 5-volt ports. So I don't just have one now, I have like 20. And I'll change that to red. And now I can plug this one into my 5-volt and this one into my 5-volt as well. So now everything's getting that 5 volts it needs, and this is creating a loop so we know it's going to work. Now the wiper is an analog signal, so I'm going to take that and just kind of navigate. I was trying to do this neatly, but that's fine. I'm just going to kind of go around here through the board and connect it to a 0. Now, because this is an analog signal and I want to distinguish it away from my digital signal, I'm going to go ahead and adjust the color of the cable. Okay, so everything's been plugged in. I'm going to zoom out for a second here, and feel free to pause the video at this point and set this up. And now let's go ahead and add in some code. I'm going to go to code, and last time I wasn't on the correct settings. Just whatever setting you're on, please make sure that it is on blocks and text, because if you just work with blocks, you can switch it to text, but you can't switch back to blocks and text. They'll delete everything. So just make sure you're on blocks and text, and you'll know you're on blocks and text if you have blocks here and you have Arduino code or actual Arduino code on the side over there. So I'm going to take all this and I'm going to throw them away, and I'm going to go ahead and create some new variables. So let's go ahead and create a sensor value. So when I write variables that are more than one word, I'll write them in camel case, which means the every other word that's connected will have a capital letter. So like sensor value, the V is capitalized. I'll press OK. And I'm also going to create a output value and press OK as well. Okay. Go over to variables, and to begin this program, what we're going to do is set our value to the analog. So find the set one, and we're going to set the sensor value, or the variable called sensor value, to whatever input is coming from the potentiometer. So what the potentiometer is going to do is it's going to send a value to the board that is equal, and I'm going to delete this stuff from last time. So the potentiometer, let me make that bigger, it's going to send a value to the board that is between 0 and 1023. So when it's off, it's going to send a 0. If you crank it up all the way, it's going to send 1023. And if you're halfway, it's going to be about 500. So anywhere between that also gives you a number. So whatever that value is, we're going to set sensor value to, go to your inputs, and grab the read analog pin. To whatever value you are getting, or to whatever value the board is reading, you're putting it in sensor value. Okay, so it's reading that value, and now that it reads that value, we can do something with it. So let's go ahead and use that to move the servo. So now that we have that stored, go to your outputs, look for the one that talks about rotating the servo, and I'm going to drop that in there. And we're going to rotate servo on pin, and our servo is plugged into 9. So I'm going to go ahead and find 9 there, to blank degrees. Now the question is, what degrees are we talking about? And we're talking about the servo degrees. And if you recall earlier, I said the servo has a range of 0 to 180. Okay, so it could go from 0 to 180 degrees, but the potentiometer can go from 0 to 1023. So no matter, like, it only takes about a fifth of the potentiometer to actually max out the servo, and then the rest of the potentiometer would be useless. It would just not do anything. To prevent that from happening, what we're going to do is we're going to remap 0 to 1023 so that it's actually 0 to 180. That way, when we turn up the potentiometer all the way, it'll be 180 and not 1023. And when we're halfway, it won't be about 500, it'll be about 90. To do that, we're going to need a map function. So I'm going to split these two off for a second. I'm going to head to the variables again, and we're going to go ahead and drop another set the output value to, go to math, look for this function here that says map on it. I'm going to grab the map function and drop it in there, and we're going to map sensor value, so variables, sensor value, which can be anywhere between 0 and 1023, and we're going to map it to 0 to 180. So what that's going to do is it'll change it, and it will store it in the word output value. Now that it's stored there in output value, we can now hook this back on and rotate our servo pin that's still a 9 to output value degrees. Because now that it will be between 0 and 180, that will make it correct. And the best way to show that is to run it. So let me go ahead and close out of the code for a second, move this back here, and start the simulation. So you can see right now not much is happening, but if I move the potentiometer, you'll notice that the servo moves accordingly. Now, real life might vary a little bit because this is really nice and really smooth. In reality, with electricity running through this, it might be a little bit like jiggity, so it might kind of move around and stuff. But you'll have a definite feel if it's working or not. And if it's working, awesome. Okay. So hopefully that all made sense. Remember, you can copy out the code, put in the Arduino software, and get that to run, and that's in video 2 if you needed to check that out. If you have any questions, feel free to let me know. Otherwise, I'll see you in the next video. Peace.